Hello everyone, Assalamu alaikum. Today we learn another interesting topic, that's one-time pad algorithm in cryptography. First of all, we know what the one-time pad cryptography. The one-time pad OTP is a cinematic encrypting algorithm that provides perfect circle when used correctly. It employs a random and secret key that is at last as long as the message being encrypted. The key is used only once and must be encrypted completely secret from any unauthorized parties. In the OTP, each character of the plaintext is combined with a corresponding character from the key using module additional to product and ciphertext. Decryption is performed by applying the same keys to the ciphertext to retrieve the original plaintext. Because the key is really random and used only once, the one-time pad is immune to cryptography analysis and provides unconditional security. The concept of the one-time pad dates back to the early 20th century, with the development during World War. However, its gained performance when independently reinvented by Gilbert Verman and Joseph Mabrul in 1917. Now we learn key characteristics. The one-time pad possesses key characteristics that contribute to its unparalleled security when used certainly. Unbreakable. The OTP is theoretically unbreakable if implemented properly. This property is stated from the fundamental principle that ciphertext produced by the OTP reveals on information about the plaintext without knowledge of the key. Since each key is used only once and it's truly random, there is no pattern and cross relation to the explanation, making cryptography impossible. Key length. The key used in the one-time pad must be at least as long in the messaging being encrypted. And third, perfect secrets. The OTP provide perfect secrets when the key is only used only once. Perfect secrets means that the ciphertext does not leak any information about the plaintext, regardless of the computational resource available on the adversary. Now we see the encrypting process in OTP, that means one-time pad algorithm. Here P means plaintext and PI means plaintext index, and K equal to key, KI equal to key index, and C is equal to ciphertext and CI is equal to ciphertext index. Now I have a plaintext that is apple, APPLE. So we know the alphabet index from this chart, and we decided to declare that a equal to 1 and z equal to 26, so that we found out our index. So a equal to 1, p is equal to 16, p equal to 16, l equal to 12, 5 equal e equal to 5, and that we have a key, and key is equal to pdahb. So we also be find out the key of index, and then we have a equation. The equation is c is equal to p plus key. So now we here is a ci, that means our p plus key operations index is 16 plus 1 equal to 17, and 16 plus 4 equal to 20, 16 plus 1 equal to 70, and 8 equal to 12, 8 plus 12 equal to 20, and 5 plus 2 equal to 7. Now we convert this index in alphabet and we found qtqtg. So we call that our apple encrypting process will be qtqtg. Now we also learn our descripting process. In descriptive process and encrypting process are also same. So there is a plain text, plain id text, key id text, and ciphertext index. Now we have a ciphertext, and ciphertext is qt so we have to find out our index from this chart, and our index also we find it. And then we have a key, our key is a pdahb, then we also we find out the key index, and key index and ciphertext index will be calculated by this equation, and the equation is p is equal to k minus c minus k. So we operation that, and we found some numbers, and we also be convert in those number into alphabet by this chart. So we find out the chart is uh, p equal to a double p l e. So we call qtqtg encrypted by Apple. Now we see the code implement of this one-time pet algorithm. We will also be coded in the Java language. So we have a main class, and we create a method which will be scanning from the user, and so will be printed the scanner what the plain text, and then it's also be asking for a entry key, and then after that entry key that will be there is a equation, the string encrypt text equal to encrypt text plain text by key, and string decrypt text is equal to decrypt text comma key. So we call the system will also be print out that encrypted text and encrypted decrypted text. So we see the encrypted part. In encrypted part, here is a key length equal to key length classes, so that we have a plain text length, and I plus plus is just plain character, and plain text plain characteristics plain integer and plain character also be a with the using by ASCII value. At the same situation we have be decrypted, and decrypted part is also be using ASCII key, and it will be modulus, because sometime we see our plain text greater than key, so that we also be repeated in our key. After that code implement, we also be output in here, where here see our plain text is a double p l a and enter key pdahb, so our encrypted text kn greater third bracket, and also be encrypting those text in descripted by vkkgz. So that's all for today. Thanks for watching.